Oh, I'm Ron Kenett. This is a joint talk with Chris Gotwalt. The short title of the talk is How to Generate Information Quality with JUMP. And the detailed title is Functional Data Analysis and Nonlinear Regression Models, Pros and Cons and their Combination, a JUMP 17 update. This is a follow-up talk to a talk we gave at the Europe Discovery Summit that you can look at on the JUMP community. It will have the same structure. I'm starting with a simple example where I'll show an application of functional data analysis and nonlinear regression to dissolution curves. And Chris will follow up with a detailed example of how you can optimize the formulation in order to match a brand dissolution curve. So it has two parts. So what are we talking about? We have tablets. We have reference tablets. That's the brand that we're trying to mimic. And we have tablets that are under test. We have 12 such tablets. We put them in a container. Each tablet is in a separate container, and this is what the dissolution test consists of. And we're going to measure the level of dissolution at 5 minutes, 10 minutes, 15 minutes, 20, 30, and 45 minutes. That will produce a dissolution curve. So we start with 12 tablets, and we have measurements. We have measurements done at 5 minutes over these 12 tablets. 12 tablets for the reference, 12 tablets for the test. Where we invoke information quality is the structure of the analysis. We have a goal, we have data, we have a method of analysis, and we have a utility measure. These are the four components that we need to elicit explicitly. And then there is a notion of information quality, which is the utility of applying F to the data X condition on the goal. So the first step is to elicit the goal. And then there's a set of dimensions, 8 dimensions. So instead of talking about this, we'll just follow up an example. The information quality workflow has different steps. We have the data preparation, data analysis, interpretation, and communication. In my part, I'm going to focus on the data preparation. Chris will expand on that with the other parts. So again, we have this data, 72 tablets under test and 72 reference tablets. We are in the pre-processing phase, the data preparation phase. Our goal is anomaly detection. We're going to do that with a functional data analysis and nonlinear regression models. And the utility is how clean is the data for conducting equivalence tests and design optimization, which will be more what Chris will talk about. So if we look at the dissolution curve on the graph builder, these are splines that are tracking the data by tablet. We see visually there is a tablet that seems to behave a bit differently. The dissolution there is slower than the others, and it reaches the plateau towards the end. The other curves are quicker to reach the asymptote. If we fit a function, use functional data explorer to this data, here are the 12 dissolution curves. The curve that you noticed before is a bit different, is T5R, here it is. This is fitting a quadratic B-spline with one knot. We also notice visually, after fitting these B-splines, three curves which dissolve almost immediately. You see it shoots up and then it stays because it basically dissolved. The whole tablet was dissolved. If we run a functional principal component cluster analysis, namely a scatter plot of the first and the second functional principal components, we immediately see T5R standing out, and this group of T1, T2, T8 being also different. If we move to nonlinear regression, this is in the specialized modeling, nonlinear models, and we fit a Gompertz 3-parameter curve. The T5R that I mentioned is now located, as you see, it's the fifth one. It will have 3 parameters: an asymptote, a growth rate, and an inflection point. We can actually run on a profiler the different curves by changing the label. T1R, which you also might remember, was the one that had a quick growth and then a dissolution. We can see it's the first one, and we get a first and second derivative of the model in the profiler that comes with this functionality. What also comes with this functionality, which is very interesting, is immediate access to the 3 parameters that identify the different growth curves. So T5R, we see very slow growth, 0.07. T1R, which shoots up to the asymptote, 0.21. If we move now and take the 3 parameters and run a multivariate control chart on the 3 parameters, we see that T5, the blue one, doesn't stand out. T1, that's the first one in yellow, and then we see T2 and T8, which we had noticed before, that stand out. This is actually one of the methods for dissolution testing in the guidance for industry. It's called model-dependent approaches. You fit models, you look at the parameters, and then you consider the parameters as data for analysis. So we did identify T5R, and then we identified T1R, T2R, T8R. In the next part of the talk, Chris will talk about a different goal, which is to find formulation and process conditions that lead to a match between a reference and the brand and the under-designed dissolution curve. Chris, it's all yours.